Okay, let's go ahead and get started. Looks like Lee's just about got all of his tacos topped over there, so we're almost ready to go.
You guys proceed.
You're just fine, Lee. So first off, who was not here last time by show of hands? Okay, and did you get a chance or do you know about the video? We were recording class every time. If you go to Teams and find the Lunch Learning team and this channel on the Wiki tab, we're going to post a YouTube link. So we're just going to briefly review what we talked about last time, but you'll probably want to go back and review that just because it tells a little bit about the prerequisites for the course and getting Visual Studio installed. For those of you who were not here last time, do you have Visual Studio Code installed? Okay. Okay, if you do not, no problem. There's a website you can go to follow along today. We will need to get Visual and Studios installed before next time's session, but you can Google .NET Fiddle. So here is somewhere online where you can write some C# code and see the output, right? So feel free to follow along here if you do not have Visual Studio, and then let's chat after our session today about Visual Studio Code. Okay, well, just by way of review from last time, we talked about C# at Health Equity and how it's used, right? The website at Health Equity uses C#. The mobile app uses APIs that are built in C#. All of our file transmission code eventually uses C# to either create or parse, or in other words, extract data from a file. And we also have our lovely cutting-edge console application that is written with C#. Okay, Visual Studio Code. I'm going to go ahead and open that. You remember we talked about Visual Studio Code as an IDE, which means Integrated Development Environment. It gives us lots of help when we're writing code. For example, syntax highlighting. If I've made a mistake with adding quotation marks, the syntax is highlighted all funky and you get red squigglies, so very helpful. Thank you, Visual Studio Code. Everyone, thank you. I'm just kidding. Don't ever do that. Okay, we talked about debugging. So, well, Visual Studio Code gives us a view of all the files. This is C# code here. A line of code is contained in a function. A function is contained in a class is contained in a file is contained in a project, and she swallowed the fly to catch the, I don't know. Anyway, that's the organization of a C# console application like we're going to build for the rest of our sessions, course, yeah. Debugging means stepping through the code line by line, okay? You're going to do a lot of debugging in this course, trying to figure out why your code is working or why it isn't working. When you debug, you set a breakpoint. You can see this little red dot right here, hopefully. This tells us when we're debugging, I want to stop on this line of code, and I could put a breakpoint everywhere, right? Breakpoint for you, everyone gets a breakpoint. Hey. All right, in order to debug in Visual Studio, we press F5. That brings up, it shows us something is happening in the console, right? And eventually it highlights the line of code that it's executing. And you'll remember at this point, we have a couple options. We can continue, meaning just let the program run from this point until it's the end of the program or the next breakpoint. Step over, which means don't go into the next function. Step into, go into the next function. If we did step into a function, we can use step out, and we can also stop the program. So that's just a very brief review of what we did last time. Does anyone have any questions? Okay. Okay, also the console, you can see that the program outputs text to the console. Hello world, I am Ben, son of Albert, and I'm here to destroy you. It's a true statement. Okay, today we are going to talk about variables, arithmetic in C#, and assignment. All right, so as we talk about variables, I just want you to think of variables like the building blocks of a program, right? This building that we're sitting in is probably, I'm no construction worker, but is probably built of steel and some Some cement. Yeah, maybe some wood. I don't know. No wood? Okay.
They use metal framing.
Right, so all of those are materials, right? They are different types of materials that make up a building. Variables are different pieces of data that make up a program, okay? Everyone's taken a math class, yeah? Yeah? No? Not up front? Okay. Please leave. I'm just kidding.
Oh, I thought that's what this was for.
Oh, this is math. You're welcome to algebra. Oh, hell. Okay, no, variable in math, right, we have like a formula. We have an equation, and we can put different values into those variables to make the equation output different results, okay? A variable in C# is very similar, okay? A variable in C# has three parts. It has a name, it has a data type, and it has a value, okay? Let me show you our first variable. So I'm going to come in here, and I'm going to say int my age is 31. Sure. Here we go. Okay, so in this line of code, I'm going to zoom in maybe. Nope. Not going to zoom.
Are you really
Zoom?
31?
I really am 31. The glasses make me look much older though. So. Okay, I can't zoom in. Does anyone see a zoom in? Zoom in.
I don't think it's loud enough.
Okay. Well, hopefully you can see that. Anyway, here we have a variable. It's got three parts. It's got a data type. This variable is a number, and there are several numeric types in C#. One of them is called an int, and it's short for integer. It's got a name. The name is my age, and it's got a value, 31. Okay, this is a variable. I want to direct your attention over to the Teams page here. Under day 2 in the glossary section, we've got this helpful table. So helpful. Okay, these are not all of the data types in C#, but these are ones that you should know so that we can do our work here in the class, okay? Very first, we've got some numeric data types. That's these lines in the table, okay? You may ask, well, a number is a number. Why do we have different ways to represent a number? And I will tell you now that when you create a variable in a computer program, you are saying, I want to reserve some space in the computer's memory, okay? If you create a byte, for example, which is a tiny number, it can hold values from 0 to 255, you are reserving less memory in your computer program than if you say, I want a long, which can hold up to that value. If you can tell me this number, I will give you all of the money in my wallet.
Which is nothing.
You can't do it. Don't change the subject. Just kidding. So does that make sense? That's why there are different numeric types. Maybe you've got a program that is creating 1,000,000 variables, so it would be very important to create the appropriate sized variable and not kill your computer program's memory, like we do here at Health Equity with all of our service jobs. So
I can say it. It's actually a prime number.
I'm going to Google it.
okay. Aside from those numeric types, so we've got types that store whole numbers, right? They don't store decimal points. We've got types that store floating point precision numbers. We also have data types that hold a single character. It's called a, here, let's take a survey because this is a huge heated debate in computer science. How do you pronounce what I have highlighted right there?
Char. I'm Italian, so it doesn't matter.
Char.
Char?
Car.
Car?
I don't know. Character.
I was planning on a 10-minute debate for this, so let's divide. I'm just kidding, don't you?
How do you say it?
I'm afraid to say it at this point.
Is it char?
It's that bad.
It's a character. Yep, it's a character.
That's how you pronounce character.
I think most people say char, don't they?
I would say char.
Kahar? And the new front runner. Okay, and we've also got strings. Strings are extremely common. So a character is a single letter or symbol. A string is as many characters or symbols as you want. And notice that a character is defined with single quotes in C#, while a string is defined with double quotes in C#. Okay? And we've also got Boolean variables. These are extremely important. They can hold one of two different values, true or false, right? So these are our data types in C#. These are not all of the data types. I've got a link down in the other resources. If you look for the single asterisk link, you can see all of the data types. Maybe you do that when you're trying to get to sleep tonight. Okay, opening back up Visual Studio Code. So those are data types, right? Lots of different data types. Quick question.
Can bool hold null values, or does it have to have container value? Or do we get that null exception error? Sorry.
So the question is, can a Boolean variable hold nothing? That's what null means in computer science. Null is just nothing, right? It's not zero, it's not empty string, it's nothing. And the answer is no. Okay, this is a very good point because all of these data types have a default value. Okay, if I declare a variable that is an int, but I don't give it a value, and then I were to say console.writeLine my age, oh, what has happened? This is not what I wanted. Okay, who can predict for me what is going to be output on line 10?
By default to
Just kidding, it doesn't work. Okay, the point is variables have default values. For numeric types, the default value is 0. So right here at this point in my program, the value of my age is 0. Right? Booleans, the default value is false. Strings, the default value is empty, so forth.
So if you use, sorry, this is getting way too more advanced. But if you use the default value, like if you don't assign it a value and you won't it just default to 0? So why did you get an error?
Yeah, this is a build configuration, which is beyond the scope of this course.
Okay.
But yeah, I could configure my build to accept that.
Okay.
Okay. So we've talked about variables have what 3 things?
Name, data type, and value.
Booyah! 5 extra credit points. Whatever that means. Okay. So here are some common pitfalls that I see when people are learning about variables, okay? Very first, sometimes we want to say this variable is my first name is equal to Ben. And this is a string. Sorry, I didn't mean var. Okay, variables cannot have spaces in their name. Right, a variable needs to be one contiguous string of characters. Contiguous. That's a big word. I heard you. Okay, also, variables must be unique. Like we said, when we declare a variable, we're actually telling the computer, hey, reserve me some space in memory. Okay, this name is mapped to an address in memory. Memory addresses are terrible, huge, ugly things. So I cannot come and declare a variable of the same name, right? Variable names need to be unique because they map to an address in memory, and I can't have 2 things pointing to the same address in memory. Question in the back.
So they can be the same name as long as they're in a different scope. I don't know.
Yeah, we're not going to talk about that, right?
Okay. All right, never mind. Ignore what I just said. They cannot be the same name.
We should keep.
Let the recording show that I am shaking my head. Okay. So variable names must be unique. Variable names cannot have spaces in them. And a common thing that I see is when I want to use my variable later in the program, learners redeclare the variable. Okay, this is declaring a variable. I'm saying save me some space in memory. This is using a variable. I refer to it by name, but I don't have to type the type of the variable out again. When I type the type of the variable and the name of the variable, that's declaring the variable. You can't do it twice, right? Does anyone have any questions about the pitfalls on variables? Brian, please repeat what I just said. I'm just kidding. Welcome. Brian just walked in. Yeah. Okay. So we're going to do some code practice here at the end. Just bear with me. I want to talk now about arithmetic operators, so math in C#. Okay, there are, once again, I'll direct your attention to the page in our Teams channel. These are the mathematical or arithmetic operators that we want to focus on in C#, okay? They're symbols that for the most part you recognize: the plus, the minus, multiplication, division, and modulus, which maybe is new for you, but we'll talk about it, okay? So when I'm doing math in C#, obviously I have to do math on numbers. I can't say Shelley divided by Aaron is equal to, I don't know, someone, pi. Okay. Okay, let's do some math in C# then. I'm going to declare two variables. Int, my first number is equal to 100. Int, my second number is equal to 300. And then I want to declare a new variable. Int result is equal to my first number plus my second number. Then I just want to write this out to the console for proof here. So who can predict what's going to be output here? Oh, I see what you're doing there. Yeah, 400. So pretty easy, right? Math in C#, we could change the operator here. Okay, very nice. So I won't go through and do each operator. Does anyone have any questions about these operators before we talk about modulus?
Just real quick, do you have to do my first number or could it just be first number? Is there a reason you're typing my in front?
No, I could name this whatever I wanted. All right, it's probably a good idea to make your variable names meaningful, right? Because you're going to go back and read this code later, and it's going to have to make sense to you. And that's what engineers do, is read other people's code and swear. So you want to try and make your variables as descriptive as possible. My second number probably isn't a great name.
Going along with that question, can you name it an integer? Like, can you name it #1, number 1?
So the question is, can I name a variable number 1? Or probably the broader question is, can I use symbols? And the answer is nope. Got to use letters.
Can you use numbers at all in, or just can't begin with it?
Yes, you can use numbers. Can't begin with numbers. I'm learning too here. I don't know. This is my first time. Okay. Let's talk about the modulus operator. So when I say that I've got 1,500, when I say whatchamacallit divided by my second number, the result is, oh my gosh, Darren.
It's not my fault.
Darren, what? You're right here, man. I know you're screwing around because you're. It's fine. You do you. Okay, division, of course, gives us the result of division, right? What is the product? Is that the mathematical term of division?
Sure.
The answer.
The answer. Okay. Modulus gives us the remainder. So who can tell me what will be output by this line of code if modulus gives us the remainder after one round of division?
You changed it to 300, right?
I did. I have 1,000 is the first number, 300 is the second, and then I am doing the modulus operator, which gives me the remainder. 100? What's that?
0.33.
0.33?
Yeah, what he said.
I didn't save. Gotta save. Gotta save it every time.
You can go into 3.
It can go into 3 times.
100. So what happened here is we take 1,000, we divide it by 300. The result or the answer is 3. The remainder is 100. And that's what modulus gives us, is 100. And you may be asking yourself, how useful is this? And the answer is it's not very useful, right? But the most common application for this is if you want to know if a number is even, right? You can do the number modulus 2. If the remainder is 1, you know the number is odd. And that surprisingly does have quite a lot of application when writing computer programs. So does anyone have any questions about the operators? Okay, let me talk about the order of operation. So everyone's familiar with order of operation, right? Because we all took a math class. Everyone signed a waiver saying they took a math class. So belly up to the bar now. Okay, order of operations. What happens first between these operators that we looked at earlier? What is the order of operations in regular math, not C#? What happens first? Multiplication? Multiplication and division do have the highest precedence. So if it's 1 times 2 plus 3 times 4, the multiplication happens first, right? Same is true in C#. And I have a table down here that shows you the order of operations for the operations that we are going to talk about today, right? If you want to change the order of operations, just like math, we surround part of the equation with parentheses, and then multiplication, division, and modulus have the same precedence. Because they're the same, we then do them left to right. Addition, subtraction, same precedence, we do them left to right. And we'll talk about these ones here in just a minute. Okay? So let's do some fun stuff. So fun. Math is fun. Your friends lied to you. Math is fun.
They were my friends.
There you go. What's going to be output here?
Your age. Sorry, my age. Oh, you took that.
We have 31, I've heard. Anybody else? I'm sorry, Randy. If I could zoom in, I'd do it. I don't know.
No, you're fine. I'm just fine.
All right. So the first thing that happens is what? 10 times 3, right? It's got the highest precedence. So we evaluate that, 30. And then what happens? What is the next thing?
Plus 5.
Plus 5, because we go from left to right. So then 35 minus 4 is 31. Okay, and then, of course, like regular math, we can change the order of operations to be this.
Oh, got old.
There you go. Good times. Good times. Math is fun. Okay. And of course, lines of code happen, they execute from top to bottom and then on a line of code left to right. Right? Okay. Let's talk about some common pitfalls that happen that I see when people are learning about arithmetic in C#, okay? So I'm going to say int my age is equal to 31. Int my weight is equal to 120 pounds. Okay. So regular math would allow me to do this. Right? What does this mean? 3 times my age. This is a compile error in C#, right? Though it's okay math notation, it is not okay C#, right? We need to always say multiplication is happening here. Okay? And then another common error is just getting the order of operations incorrect. I've got 4 code-alongs here that are some conversions or equations that have multiple steps, and you will have to you have to change the precedence with parentheses, so just make sure you get that right. Okay, and also sometimes I see something like this. Like, I don't even know what's going on here. Don't do this. They try and declare 2 variables on the same line and then do the multiplication in between. Just don't do that. Okay. Any questions about the arithmetic operators? We're going to talk about one more thing and then we're going to get to code along. So assignment operators. I'm sorry, were there any questions? I asked if there were questions and I didn't even look up. I'm now going to look at each of you. Okay, assignment operators. So this operator we didn't really talk about, but I think we all understand it, right? We're saying we're going to assign the value 120 to this variable. Okay? This is just the regular assignment operator, but C# lets us, or gives us, what we call syntactical sugar. Okay? And that's because some really nerdy guys were like, how can I write as little code as possible and make it short and sweet? So I want to show you that I've got int my age is 31 and my birthday is today. So I'm going to say my age is equal to my age plus 1, right? So what is the value of my age on line, after line 10 is done executing? It's 32, okay? You see how I have repeated the reference to variable my age twice. I've said, I want to take my age, I want to add 1, and then I want to store it back in the variable my age. Okay, there is a shorthand way to do this, right? And this is where we get into the other assignment operators. So this is exactly the same as this, right? It's abbreviated syntax, it's syntactical sugar. All this is doing, this is called a compound assignment operator, and it does addition. So all it's doing is saying, I want to add 1 to whatever is on the left-hand side of my age and then store it back in my age. So this line, line 10 and line 11 are exactly the same. They just take my age, add 1, and assign the result of that addition back into my age.
You do equals plus?
No, you cannot.
Can you tell us why you would do that?
Syntactical sugar, it's just as you write more code, people want to be as brief and write as little code as possible. So rather than referring to the variable twice, because this is a very small variable name, but when you get a variable name like file imported at day and you have to type it out twice, then yeah, you're writing code forever, right? So it's an efficiency thing, but you don't have to do it, right? This is, like I said, these two things are exactly the same. I think one is probably a little more readable than the other, right? By saying my age is equal to my age plus 1. So you should just be aware of them. So those operators are all right here. I knew I put them there, okay? All of the assignment operators. Okay. It is time now to do a code along assignment. We have a question back here.
Is it possible to alias variables, or does that not exist?
So the question is, can we alias variables? And the answer is no. When we talk about objects, which will be one of the last things we talk about, an object can point to an object, but you're probably familiar with SQL, I'm telling, because you asked that question, and no, the answer is no. So. Okay, let's do a code along. So I want to write a program that is going to convert miles to kilometers. Okay, the way you do that is you multiply, well, let's just Google it. don't want to say the wrong thing.
We want you to.
Miles to kilometers. So in order to convert miles to kilometers, you take the number of miles and multiply it by 1.60934. Okay, so let's write a program to do this. I'm going to declare a variable called number of miles, and I'm going to set it to 56. Okay, then I'm going to declare another variable, and I'm going to do an error here, see if you can catch me. Int conversion rate is equal to 1.609. Does anyone, what's my error here?
You can't have decimals in your.
Right, and int is for whole numbers. Very good.
Only taken this class 5 times.
I'm actually going to use a double. Okay, so I've got my number of miles. I've got the conversion rate. It's abbreviated from what Google showed us. All right, now all I need to do is take the number of miles, multiply it by the conversion rate, and store it back in another variable. So I'm going to create another double variable, and I'm going to call it kilometers. And I am going to say number of miles times conversion rate. Okay, and then I would like to output that to the console. We're going to talk about console input and output next time. So for now, just know that console.writeLine is the line of code you need to use to write something out to the console. And I want to write the value of the kilometers variable. So I'll give everyone a few seconds here to get this code typed out if you're following along. Does anybody have any errors they're encountering at this point?
Is there a reason you put a space between the two doubles?
No, no reason. I could do that. Okay, I'm going to pause the recording and walk around and make sure everyone's good. Okay, we've troubleshot a couple programs here. One thing to note is you always need to save in Visual Studio Code your changes. So you see how there's a dot right here. This basically tells me I have unsaved changes. So I'm going to put my cursor here on a line of code, hit Control-S, and that changes to an X. Tells me I no longer have pending changes. So if you are not seeing the output that you expect, make sure that your files are all saved. Control-S will save a single file, the file that's open. Control-Shift-S will save all files. Okay. With our last 17 minutes here, we're going to continue to work on this code-along assignment, but I've also got several assignments for you to work on here. And should you choose to do so, you can work on these assignments after class. Feel free to send me a message on Teams or email. I'm happy to chat with you whenever you need. Probably not after 10 p.m., let's be real. But yeah, so here are some extra assignments for you. So I want you to do these 4 things in order to practice what we've learned today. I want you to create a program, or just use your same program, to store your name, birth date, and computer password in variables, and then write them out to the console, and then show them to me when you have that done. And then I want you to do a program that converts inches to yards. For your information, 1 inch is typo, inches to centimeters.
Yeah,
Thank goodness for that. 1 inch is 2.54 centimeters. Yep, create a program that calculates the surface area of a cube. This is the formula. So it is A squared times 6. That's how you calculate the surface area of a cube. So we didn't talk about how to do exponents in C#, but a squared is just a times a, so you could probably do that. This is definitely one where you want to make sure to get the order of operations correct. Okay, and then the final one is I want you to calculate how many acres are in a football field. So a football field is 120 yards, that's 100 yards plus 10 for each end zone, by 53.5 yards. I want you to calculate how many acres there are in a football field. So in order to do that, you first need to convert the yards to feet and then get the square footage by multiplying those converted values by each other. And then once you have the square footage, you divide that by 43,560, and that will give you the number of acres. All right, so these are all things that we just need to create variables and do some calculations, output the result to the console.
How much is the width? 53.5, you said?
53 1/3 yards. Yep, and again, all of these are here on our Teams page. So, and of course, useful links, some citations down here. Thanks to our sponsors. And any questions before I end the recording? Okay.